let us talk about drawing trig graphs. And I think one of the things I picked up in the last lesson was that definitely a lot of students would benefit for some extra practice, and also how to use your calculator to assist you in this process. So say, for example, I'm going to show you now, if I want to draw the graph of, say, y equals 2 sine x. Now, all that has happened to that graph is that it's changed its amplitude, and we probably covered this in the previous lesson. Now, in terms of using your calculator, how would you use it? Well, you need to know a couple of things. You need to know the period of the graph. So the period of the graph here is 360, and that's because nothing has been changed. So that's the period of the graph. The step size in the case of sine and cos is just the period divided by 4. In the case of tan, it's just the period divided by 2. And that's because the number of times you lift your pen is different for tan than the sine and cos graph. And then sometimes you need to know the amplitude, although your calculator will kind of work that out from the formula, but in this case, the amplitude is 2. And then the final thing that you need to know when you draw a graph is the domain. And in this case, the domain is 0 to 360. So how do I get my calculator to help me? So I go to Mode, and then I click on Table. And now I'm going to key in my calculator, the formula that I've been given. So I go 2, and then I'm going to go sine. Then I'm going to go alpha x, close bracket. Then I go equals, and I've got 2 functions turned on, but I don't need the second one. So I go equals again. And then I go, where do I start? At 0. I end at 360. And my step size is going to be 90 degrees in this case. And then I go equals. Now, a lot of you would be able to draw this graph out of memory, and that's not a problem. Like, you might know that the sine graph always starts at 2. Let me here. But if you're unsure, or you're under stress in the exam, or whatever it is, this gives you a handy way to just kind of make sure that you're on the right track, or just to check. So we get 92, 180, 0. And then I click the down arrow to get more points. And I get 270 minus 2 and 360, 0. And what that does is it shows me the key points that I needed to draw this graph. That should be a bit more curved. Let's try that again. And obviously we have to label our graph. And often in exams, they'll ask you to label these turning points, but for now, I'm going to leave that out. So that's where the calculator can be quite handy in assisting you. And so today I want to practice more and more complicated trig functions using your calculator. Can you give me a thumbs up if you've understood my basic example, or ask a question if you're confused, or give a thumbs down if you're totally confused? Okay, awesome. Okay, so then let's use our calculator to help us as we look at more and more exciting trig functions. And I suppose yes.
Can you please make me co-host?
I can, yep. Make co-host.
Thanks, Mr.
Okay.
Ace.
All good. Okay, so I'm going to stay with the domain 0 to 360 for now, because, let's concentrate on the interesting stuff. If I say to you, draw the graph of sine 2x on the domain 0 to 360, the period of the graph is not going to be the same anymore, and that's going to influence the step size. The amplitude is going to be the number in front, or the absolute value of the number in front. So this is 1. So this is just going to be 1. I want to know from the class, what is the new period of the graph going to be? And what is the new step size going to be before I go about trying to draw this graph? Or even what the transformation is. What does this 2 do to the graph that I need to know about? Okay, so Loretta is helping us out. Anybody else agree or disagree? So the period of the graph is going to be 360 divided by whatever the number is that changes the period. And this number in front of the x changes the period, so it's 180. The step size is going to be 180 divided by 4, which is 45 degrees. And the step size is normally just the size that we need to know when we're drawing the graph. So it's the number of times we kind of lift our pen. And that's why we break it up into those chunks. Okay. I want everyone to try and use the calculator function or out of their own understanding and try and draw this graph. And once you are done, I want you to say done in the chat. So off you go, see if you can draw that and see if the calculator is helpful. I will do it on the calculator once a couple of you had a go. I agree with Lebo. If there are any questions, please do ask. We're happy to assist where needed. So I'm going to hit equals 0, 360. And the only difference is the step size. Then I get this. D60, 90, so 45. It's 45. Yeah. Lesejo, what's your question or comment?
Sir, do you
Yeah.
usually just say 45, like just as a general baseline step?
Okay, the way it works is you take the period of the graph. So normally it'd be 360, and you divide the period of the graph by 4 if you're dealing with the sine and cos graph. Okay, and that's because normally when we draw it like in a up, down, down, up motion, whereas the tan graph is a bit different. It kind of goes like this once, twice. So the step size will be whatever the period is divided by 4 in sine and cos, whatever the period is divided by 2 in tan. But remember, the period can also be changed based on the number in front. So if I said a bit more there, but
But you said for this one, it's 45.
Yeah.
But like 360 divided by 4 is 90.
Yeah. Okay. So in this one, the basic period of the graph was 360 to start with, but then the 2 in front of the x affects the period. So the new period of this graph is actually 180. And what that's telling me is that it takes 180 degrees to do a full cycle. Okay, so that's the period part. Now, to find the step size, and let me get a different color. Okay, I can't get to my colors right now, but you divide that new period by 4 to get the recommended step size, which is 45. And so that's why when I'm drawing a dot every 45 degrees.
So when you have a sine or cos and then in brackets something multiplied by the x, that affects the period.
Yeah, that's pretty much it. Yeah.
Okay, thank you.
Cool, cool. So now let's go back to this journey. So we have there. Actually, let me reveal more of these points. So it was 225, 1. So where's 225? 1 is here. And then here, 315 is -1. And this is here. So let me.
Mr. S.
Yeah.
Sorry, Mr. S. I see Dawn is also asking what the effect of the 2 is. Can you please explain it again?
Totally. All right. So the number 2 over here, which just kind of rocks up, and this is very different to the 2 in front, they do different things, is what I'm telling you at the moment is a little bit like just believe me. But what I'm saying is take whatever the period of the sine graph normally is, which we know is normally 360, and divide it by whatever the number is in front here, which in this case, it's 2. So now the period of this graph is 180. Now, if I look at the drawing, which I have the sort of fortunate opportunity to do, show you the drawing, you can see that the whole graph is drawn within 180 degrees. And so that's why you see that the period is 180. It's just that it then does another cycle of the graph in the second 180. I suppose that's a little bit of a separate point though. Now, how do you draw the graph when you draw it? Well, the step size is just going to be basically the recommended number of dots that we draw in it before we join them. And we take the period, whatever it is, and for the sine and cos graph, we divide by 4. For the tan graph, we divide by 2. And in this case, we get 45. And so that's why these are going in 45-degree jumps. That's the step size. So basically, at Dawn, it basically says the wavelength, or it squishes it horizontally. It's almost like it used to take all of this to do one sine graph. Now it only takes this much. And so we said the period has changed by a factor of 2, or it's been squished horizontally by a factor of 2. Or the simplest way is to say the period is halved, I guess. That's another way of saying it. Okay. Let us do another one that is somewhat related to this. In fact, give me a thumbs up if you're okay, and then I'll move on. I'm going to do another version of this. Thumbs up if everyone is feeling okay, or are there more questions? Okay. All right. So let's do, since cos hasn't been getting a lot of attention, let's give cos some attention. So I want you to draw the graph for me of y equals cos 3x. And the domain is going to be 0 to 360. And I want you to think about, what do you think the period is going to be for this graph? What do you think the step size is going to be for this graph? And it's always good to think about what the amplitude is as well. But I don't want to give any more away. If you ask me a question, maybe you can draw me into a conversation. But for now, I want you to try and do that, but you absolutely are, since today's lesson is focusing on how to use the calculator, I would suggest giving that a go. Almost, Loretta. So think about what is the number in front of the X and what does it do? So there's a 3 here. And so if you think about what happened in the previous example, maybe I can do to zoom in for a second. What did we do in that example and how could we mimic it? I think the normal period of the cos is 360, but we should divide by 3. And I think that is a good way to get going. Oh, there we go. You were ahead of me, Loretta. Sorry. The step size. Exactly. And the amplitude is just the absolute value of the number in front, which is 1. And let's see, can we draw this now? That's the question. Nicely done, Stephanie. Nicely done, Loretta. So let's see what our calculator has to say about this. Three alpha x start at 0, end at 360. Step size is 30. So let's put some dots in the game. So, well, let me put some of these on too. So 0, 1, then 30, 0, then 60 minus 1. I have to use my down arrow to help me. Let me actually make this bigger so we can got that. Let's see what we can do. Where were we? 152. There's a lot more points in this. But seeing a bit of a pattern though. Once you see that pattern, it actually gets a bit easier. And so sometimes when you're drawing this graph, sometimes even just using the calculator so that you get to see the pattern, because once you've done one period, because these are periodic graphs, they repeat. Really, all you're doing is repeating. Oh, sorry. All you're doing is repeating what happened. So I'm going to give a bit more time because this is trickier, but just let me know in the chat when you're done. Otherwise, also, if you want to ask a question, happy to assist where I can. So when I start drawing this graph now, I'm going to use the step size to kind of, as I draw it. So the step size was 30. So I draw it 1 step, 2 step, 3 step, 4 step. And now I've finished a whole cycle. Dum, dum, dum. And what we notice is we've actually fitted. So that's 1 complete cycle. That is, wait, Yeah, so it'll be 120 to 240 is another complete cycle. I'm kind of just coloring it in because I can, but you get the idea, right? So there's actually 3 complete wavelengths that have gone like that. So what is the standard formula for these graphs is what Dawn has asked. Okay, so Dawn, it depends on what type of standard formula you're talking about. You know, there are 4 different types of shifts that you can learn about, but I don't want to put them all together. Well, I'll write it now often, but it looks more scary than it really is. So like actually people write it in different ways with different variables, but there's basically 4 changes that you need to know about. And the transformations are the amplitude change. This one is the period change. This one is a horizontal, this is a vertical shift. And this is a horizontal shift. But I prefer to do them individually, and then we can join them later in the lesson. Okay. Oh. Okay, everyone feeling okay? Can we do one more before the break? Or give me a thumbs up if I can move on. Okay. Or, okay. So this one's a little bit easier, but I just want to make sure you've got it in the tank in terms of understanding. I want you to draw for me the graph of y equals cos x plus 1 over the domain 0 to 360. So that is what I want you to try and draw. I'm going to let you figure out what's going on there. If there are any questions, please do ask. But and notice how the angle bracket is closed. So there's no interfering with the input to the cos function. This is a separate +1 on the end. Okay, so I have cos. I have to be careful about how I put this in. Close the bracket +1. Now, what is my step size going to be? It's not going to be 30. That was from the previous question. So my step size is just going to be, well, the period is still 360. And so my step size should just be 90. Ah, Loretta, yes. The lowest point is 0. Okay, so this is interesting. We've taken the cos graph, and if I look at my calculator, it says the same thing. It never gets negative. So let's just trust the calculator for now and then see what happens. So 0 to, let's go 1, 2, -1, -2. So let's say 0 2 is this point. And then 91 is that point. 180 is that point. 271. Oh yeah, it doesn't go down, it goes up again. 271, and then 362. Now, even though at first it felt a bit shocking, to me, it sort of makes sense now when I think about what does this +1 actually do? Normally, the cos graph is between 1 and -1. But it feels like this +1 has lifted it so that the graph now occurs completely between 0 and 2. So it's done a vertical shift. And so actually it does make sense. So I want to see if you can tell me in the chat when you feel like you finished drawing it, but I'm feeling quite confident now about it's just a good old-fashioned vertical shift upwards. So if I draw it, it's just going to be these are my points along the way, and this is y equals. We can even compare it to the one above. You can see how it's different. It looks different because the period has been changed, but the basic shape of the graph is still down, down, up, up. And that's because, yeah, that's the cos graph shape. I do like that I can zoom in and zoom out so easily. Okay. I think we're making good progress, but you know that we're humans, and because we're humans, we need to stretch our bodies. We're not designed to just sit on chairs all day. So let us turn on our cameras, stand up, and have a nice stretch. Oh, there we go. Stretch
Please
it out,
join us
everyone.
in the
Stand it up,
stretch, guys.
shake it out.
Give
and
your mind a
just
break.
Turn on your camera so we can say hello to you.
Yes, let's see your lovely faces.
Hi, Shoshana. There we go.
Shout out to Lesego and Shisana.
There we go.
Don't be shy, guys.
Oh, stretch it out. Oh my goodness, my shoulders are so happy with me right now.
I think our people are feeling shy today. Come on,
Don't be
guys.
shy.
Last day. Let's see your faces, please.
Yes, you want to see exactly. I want to see the people of the room. Oh,
We're all being silly together, so
exactly.
don't feel embarrassed.
You guys should see me in normal class if you think I'm silly here. You can imagine how I can be quite persuasive about stretching in a physical room.
Oh, Lesego says it's been a bad day for some of them. I'm sorry to hear that, Lesego.
No, we do understand that everybody is at different places. We just know that a bit of exercise and getting up is super good.
Gets those endorphins going. Feel good hormones.
Okay, yeah, exactly. Endorphins. Guys, you got to get some of those. Change your life. Okay, let us do a brain break. So here is the brain break for today. Okay. No, you guys are so quick. I thought some of you would be like, okay, 1 times 2 times 3, and go on that whole journey. But what you have figured out is that on the number pad is also a special number called 0. And so anything times 0 is just going to be 0. So well done to Dawn and to Chloe. You smashed that out the park. Chop, chop.
Well done, guys.
Okay.
Much quicker than me.
All right. Now, before we continue, in the second part of this lesson, because the second part is going to be me making sort of the functions more interesting and difficult. Is there anything in particular about trig graphs that you want to know, or are you happy with the kind of approach that we're taking at the moment? Because I'm just going to show you different combinations of how the functions work together and how we deal with that. But I'm happy to change if it'll help anyone. Okay, so yes, so Dawn, in the sine and the cos graph, so sine and cos by default have a period of 360, but the tan graph has a period of 180. And that's because if you think of its basic shape, like the tan graph only really has kind of two halves, whereas the cos graph, it has these sort of four quarters, or these, these four steps, and it takes 360 to do that. And with the sine, it's 90, 180, 270, 360. Now, while we're doing the tan, because we must give tan attention now, the tan graph has these asymptotes that occur every 180 degrees. And so we'll try and work some tan graphs into the second part of the lesson, but it's just good to be aware that when you draw it, it's only really got these two halves, and that's why we have the step as just dividing by 2. Are there any other questions about trig graphs you want to ask? Or maybe something that you're unsure from the year and you're like, oh, otherwise we'll go back to those examples. Okay. Awesome. Let's do this. Oh, wait. Okay. I need some more graphing stuff. So let me rub this out. And you know what? Actually, in fact, I don't even need that. Let's change the, should we change the domain to make it a little bit more exciting here? Switch it up. So I've now got it turns out trig graphs do go into negative angles. So that's always good to remember. Let us combine two things. So let us, in fact, we haven't done the tan function yet. So why don't you draw for me y equals tan x over the domain minus 360 to 0. So I want you to draw the tan graph for me over the domain minus 360 to 0. And I'll start doing my working out. Now the step size is interesting. It's not going to be, well, maybe it is 90. Let's see. The normal period of the tan graph is 180, but I divide it by 2, and so my step size is 90. So this is interesting. There's an error there, and there's this, and then what else is there? Minus 90 also has an error. And then 0. What do you think is causing the error? Does anybody have an idea of what's causing the error? Is it a math teacher mistake, or is that error telling us something? Ah, these are the asymptotes. Exactly. So the graph is undefined at those points. And so what I'm going to do is we put a dotted line to indicate the asymptotes. Now, at this point, if you don't know the shape of the tan graph, you may say, okay, I need more points. And you can put more points in. And if you change the step size, you'll get more points. All right. So just to show you how you would do that, if you hit AC, I go equals, everything's the same. If you want to change the step size to 45, what will happen is you'll now get points, say, for example, minus 315 is at 1. So minus 315 would be, let's see if it's 45. So this, but you don't, okay, well, let's do this. We'll make that 1, that 2. So minus 315 should be here, is going up in 270. Yes, so that's going to be halfway between here. So what you can do then is you can imagine that the tan graph is positive, so it looks like that. And then on this side, what's going to happen is it's going to look like this. Now, on this side, it's going to go, let's have a look. Like that, you can imagine. So if it's helpful, so what is the step for such a graph? Is it 90? So basically the step size for this is 90. And the reason it's 90 is because that's generally how many, basically it's, whenever we draw the tan graph, we draw it in lots of 2. But in this situation, if you don't know, you don't always need an extra point, but if you need extra points in your graph, what you can do is you can change the step size to be a smaller number, and then it will give you more points. So say, for example, now I have minus 315 is 1. So minus 315 is here, and that's in line with 1. Now, if I go to 270, it's an error. Minus 225 is minus 1. So here's minus 225 on here, and you can see that it's in line with minus 1. So it just helps you. If you weren't sure where the graph should be going, it gives you an extra hint. But at some point, if you have too many points that you're plotting from the calculator, it'll take so long that it's just not worth it. But I'm just showing you, if you're unsure, how you can get more points. The other way to do it is also just to say, what is the value of tan of x at, just normally? Yeah. Does that help? Are there any questions about the tan graph? Okay. Cool. Okay, well then let's do another type of shape. I just wanted to make sure we did spend some time drawing the tan because it's a bit different. But let's talk about a combination of two things. And then we'll also talk about horizontal shifts. So say I want you to draw the graph now of y equals 2 sine 2x, and I want you to do it on the domain minus 180 to plus 180. So what I've done here is I've changed this number and I've changed this number. And I want you to try and draw it. I've also said that I'm restricting the domain from here to here. See if you can do it. Draw me that.
This, guys.
Yeah. Yeah. What is your question?
So are there supposed to be brackets around?
Yes. Okay. So I'm being a bit lazy here. You're quite right. There should be a bracket around that to show you that that is the input angle for the sine function. Yeah. Good spot. Thank you very much. think I'm spotting a bit of a pattern here. That's right. So what I'm seeing with this graph is that the period has been halved. So within the 360 degrees, you get 2 complete cycles of the sine wave, but it's also been stretched vertically. The amplitude is now bigger. And so if I asked you a question about the range of the range of the graph is actually between 2 is the highest value, and the lowest value is -2. So it's been stretched vertically and compressed horizontally. But in reality, drawing it is a very similar process. The calculator definitely does give you a nice check of whether your intuition makes sense. And for a sine graph, generally you would start going up from 0. So that the shape of the sine graph is still the same. Thumbs up if you feel okay. Thumbs down if you are less certain. Okay, let's squeeze in one more. Let me go grab another. I've just thought of a type of thing that I haven't done. So you are going to draw me the graph of y equals minus cos x plus 1. And you are going to draw it for me on the domain. Let's make it 0 to 360 again. Now, something interesting, well, who knows what is happening exactly, but I'll leave that to you for now. Try and draw the graph minus cos x plus 1 using the tools that you have at your disposal. It's interesting to think, what does a minus sign in front of the cos do? I guess we don't have to think about it too much because the calculator will give us some idea. But Who wants to tell me what they think this minus sign does? I think most of us have a pretty good idea about what this does. Yeah, Leseko, what do you think the minus sign does?
This is the first time I answer in a long time. So it flips it.
Flips it. Perfect.
Yes,
So it reflects it over which axis do you think it is?
The x-axis.
You are winning at life, indeed. Okay, so the cos graph normally would go down from here, but in this case, okay, when it gets flipped over, it's going to be going in the opposite direction, essentially. Or let's have a look here. So normally it would go like that, and then it's reflected over. So what do we have? We have this, 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 and that, which is the reflected shape of the normal cos graph. Cool. Any questions or comments about that? So the other thing you can do, so if you imagine a normal cos graph would look like this, right? So that's the normal cos graph. Now, if you have to reflect that and move it up, can you see how it's almost like, instead of having the sort of the bowl going down, the bowl needs to, the mountain, instead of the mountain facing down or being a dip, it has to be a mountain. So that's the reflection part. But then it also has to be moved up by 1 because of that. Does that make sense? Okay, that was a bit of a tricky one. But the main thing is, using the calculator, you have these points. So just think, normally the cos graph goes down, down, up, up. Now, because it's been reflected, it's going up, up, down, down. So it's going the opposite way each time. Okay. All right, I'm going to end it at that point because that was probably the toughest one we've done today. I'm interested, was having the calculator on the side particularly helpful today? I'm just interested to know if I should, yeah, I can sort of include it in future lessons. So interested to know your sentiments. And then we're going to wrap it up for today. Okay, awesome. So